Yeah, so the second talk will be given by Augusto Fraga Giach. So Augusto works at the Brazilian National Synchrotron Light Laboratory, the Sirius Light Source, in the Electronics Instrumentation Group. His main role is developing embedded firmware for FPGAs and microcontrollers for beam position monitoring, fast orbit feedback subsystems, and fast data acquisition for X-ray area detectors. So Augusto, please.
Thank you for the introduction. This talk today will be about open source simulation, the landscape, and the advance we had towards mixed language support. So this is a quick overview of what we'll talk today. First, why it matters, because some people think, well, we have good commercial simulators and we have money, and well, why would you use an open source simulator? Then we will see an overview of the tools that are actively developed for simulating Verilog and VHDL designs. And then I will talk about the mixed language simulation, something that has been recent development that previously was something that only commercial simulators could do, but now you can do with open source tools. And then last, I will talk about the challenges we face with open source simulators. So, quick introduction. Why it matters? Well, the first most obvious would be that there's no licensing costs for open source simulators. But I think one point that is much more important is because it's much harder to manage license closed source commercial simulators, especially when you have to integrate with continuous integration, continuous delivery flows. There's no artificial limitations on runtime, lines of code. Sometimes you can get a commercial simulator for free. I think the Altera Quartus provides a CastaSim or ModelSim free version, but it has some limitations. I don't know if it's on runtime or lines of code. Cross-platform, okay, that most commercial simulators support Windows and Linux, and most FPGA development is done on these platforms. But if you are a Mac OS user, you have basically no options. And it's cross-architecture, so it's good that it can run on any modern CPU that runs Linux or any kind of Unix operating system. So the tools, I have listed here only the actively developed tools for simulating VHDL and Verilog. Because there's some other tools, if you search, that are VHDL simulators and Verilog simulators, open source, but they are not actively developed, so I don't think it's a good idea to keep using them. And from the VHDL side, we have GHDL, is developed by Tristan. I don't know if Tristan is here. I know that he works for CERN. And thank you, Tristan, because this tool was what made me really understand VHDL. And now, more recently, the NVC simulator, I don't know if you were familiar with, but it started in 2016, I think, by Nick. And it's a completely new implementation of a VHDL simulator. And it has a lot of interesting new features. From the Verilog side, I am a bit biased here because I am mostly a VHDL developer. So I just did a quick search about Verilog simulators. So of course you have Icarus is the most famous Verilog simulator, and it has a very good Verilog support and some support to system Verilog. And Verilator is the new simulator that aims to have a much better performance than Icarus, though it has less support for Verilog. But it has a reasonably good support, so it does not makes sense to just discard Verilator just because Icarus has a better support overall of the language. And recently NVC, that I'll talk later about the mixed language simulation you can do NVC. Here, I did a table for the features we have with these open source simulators. First, Icarus has kind of a VHDL support, but it's not in a usable state, nor does have a good documentation about it. I did some tests, and it cannot handle even some basic VHDL designs, and I think because it's hard to map the VHDL language to what was only Verilog simulator, because the way VHDL works is a much more complex language. It has different scheduling mechanics than Verilog, and so it's not very useful, unfortunately, and it's not actively developed anymore. PSL is something that only concerns VHDL simulators. PSL is property specification language. I'm not very familiar with. I have tried before when I tried to learn some things about formal verification. It has an excellent Verilog support overall. I read that in the early days it had even a better support than some commercial tools. So this is good. And it has experimental synthesis support. I didn't know this before researching, but it's not actively developed anymore because, well, now we have Yosys, and Yosys is much better at synthesis than Icarus Verilog is. So this feature is currently being deprecated because why would you use Icarus Verilog if you have Yosys that can target a lot of different FPGA families? And it has a co-simulation interface with VPI, so it supports a subset of VPI. Verilator does not have any kind of VHDL support, no PSL support in this case, and it has a good Verilog support, though not as good as Icarus Verilog, but it has become better with time. It can run, for example, UVVM today, so it's not like some years ago that you could only simulate synthesizable only code. It can do top-level Verilog test benches, so it's getting very capable and has a good support for overall a lot of Verilog standards. And the biggest advantage of Verilator over Icarus Verilog is that it's much more, the simulation time is faster because it compiles to native code, and Icarus Verilog does interpretation. It has no synthesis support, nor does it aim to have any synthesis support. And it also has VPI, but you can integrate with System C from what I saw. So it's a very flexible simulator that can be quickly integrated with the software world. And for the VHDL simulators, first we have GHDL. I think GHDL has been developed over 20-something years, so it has been started a long time ago. And it has a good support for a lot of VHDL standards. I would say that VHDL 2008 is very good, very well supported by GHDL. And it has experimental support, basic support for VHDL 2019. It has some support to PSL, but I never tested a lot of this, so I can't comment. It has no Verilog support, so it's a VHDL-only simulator. But one thing that GHDL can do that NVC can't is synthesis. And it can do generic synthesis, like you have a VHDL 2008 code, and you have to produce some VHDL 1993 netlist so your synthesis tool can understand your code. so it can use to generate VHDL 1993 designs in a flat hierarchy, and also can use to generate Verilog design. So if you have a complex VHDL 2008 design that you have to run through a synthesis workflow that only supports older standards of VHDL, you can use GHDL to translate this. Or if the tool does not support VHDL and only Verilog, it can also do this. And one thing that I found very interesting about GHDL is that it can be integrated as a plugin of Yosys. So you have mixed language support for synthesis and a completely open source flow for synthesis. Of course, only for the FPGAs that Yosys supports. But this is something that is very interesting in the open source synthesis landscape. For code simulation, interestingly, GHDL supports VPI, even though VPI is a code simulation interface target for Verilog. And it has something that is called VHPI Direct. It's not standardized like VHPI, but it's a very simple interface that was developed by Tristan for GHDL that you can call native libraries from the VHDL codes. You can map functions and procedures. And I have used this before, and it's very useful for some simple code simulation strategies. So, and later, NVC is the newest VHDL simulator that I think it started in 2016 by Nick. It has also wide support for VHDL standards. One thing that I found interesting about NVC is that it has a very good support for VHDL 2019, good enough to run OSVVM, the verification framework, using VHDL 2019. It also has partial PSL support. And the interesting thing that became a reality just 2 years ago is experimental Verilog support. And I will talk more about this later. It has no synthesis support, and it does not aim to have synthesis support. And it supports a subset of VHPI, and it also supports VHPI Direct. It tries to copy, more or less, the VHPI Direct API from GHDL, but it has some differences. And the other side of the simulation, when you finish your simulation, typically you want to see the waveform. And you have two waveform viewers that are relevant here. First is GTK Wave. It's a very consolidated waveform viewer. I think almost everyone have used the GTK Wave in some time because it can open a lot of waveform file formats. It's written in C and is an older code base and uses the GTK toolkit framework. One problem I have with GTK is that it cannot easily be cross-compiled to some operating systems. I would say, especially for macOS operating systems. And even though you can compile and run on Windows, the build is more complicated. So it's not as portable as the Surfer waveform viewer. That's a new waveform viewer that is developed in Rust. And it has excellent cross-platform support for Linux, Windows, macOS, and even WebAssembly. One thing that I find amazing about Surfer is that you can run it in a web browser. So any operating system that has a web browser that supports WebAssembly, you can run, and has a reasonably good performance, even though it's not native code. So this is interesting. And you have to do no installation whatsoever. Just open the Surfer official web page, and you can see the traces of your waveforms. So here, print screen of GTK Wave. It's fine. It does the work. You can see the waveforms. One feature I think GTK wave lacks is a way to store the waveform state, the window state in a file. So sometimes you're doing some deep debugging and you have a lot of signals organized in some way, and you have to close the waveform viewer, and you have to restore the state it was before, and it has no support for this. I don't know why. I did add support in a little hacky way using TCL, and I opened a pull request, I think 3 years ago for GTK Wave, but it was never merged. But overall, it has a reasonable set of features, and it has good performance, but has the problems I mentioned before, like no good cross-platform support, especially for macOS systems. Well, and now, okay, now we have Surfer is the new kid in the town, is a new waveform viewer that has a modern interface and is much more, I think it has a lot of interesting features like frame buff viewing, trace interpreting, so you can extract, see a trace of instructions from the waveform and can decode these traces. And it is actively developed and is in a way much more capable now than GTK Wave is, and has a code base that's easier to navigate and add features. So about the mixed language simulation, this is the most interesting thing. For a long time, we didn't have open source simulators that could do mixed language simulations. So you have to do some kind of hacky way of using source code translation, so translation of VHDL designed to Verilog or your Verilog designed to VHDL and run on a simulator that unsupports one language. It kind of works, but it's not ideal because the translation is not perfect. You cannot map exactly VHDL to Verilog and vice versa. And you could use GHDL to do Verilog synthesis, but then simulating a netlist is not ideal. It's very hard to understand because it is a bit obfuscated. And you could do some synthesis also with YOSIS and GHDL, or use this CXX RTL output of the YOSIS to do a simulation of mixed design, but it only works for synthesizable code. And NVC has added experimental Verilog support, and this is very interesting because it's a true mixed language simulator. So it does not use language translation. Verilog I compile like VHDL sources, and they share a common simulation kernel. So in this way, you can have traces that are much easier to understand. No kind of netlist obfuscation is done here. And although it's very experimental, it's actively developed, so you can simulate some Verilog designs. And I did some simulations with one DSP design we did in the lab, and it worked very well, so I was impressed. And the developer, Nick, is very much active in GitHub, so if you have some design that is not working, you can just tell him, you just open an issue in the GitHub page and it gets solved quickly. So it's very cool that we have a simulator that is closing the gap between commercial simulators with support to mixed language simulation. Some challenges we have with open source simulations. First, interactive debugging. Debugging RTL code is a bit hard because it's not, the debugging model is not the same as you would use with software. So breakpoint debugging is a bit weird because the code is inherently parallel. But I saw that you can do in some capacity, for example, in Model C, you can use breakpoints to at least simulate some instance of a core or to see how a function works. And so debugging is a bit more involved, so you have to understand what we really want before we implement this in open source simulators. And this could be used for evaluating variables as it cannot be dumped like signals in VHDL. So of course, no open source simulator supports interactive debugging. And delta cycle visualization also would be something interesting because you could see how the signals work even though it's in the same delta cycle. I know that Model Sim supports this, but no VHDL supports, no open source simulator supports. So I have to run here. So the last thing I have to talk is about encrypted IP models. Unfortunately, something that open source simulators cannot solve alone because this depends on the vendors. I don't know if it could be some compromise in using some kind of obfuscated netlist so you don't extract the design from a protected IP. Because anyway, commercial simulators use some kind of obfuscation to hide its private keys. If someone try to reverse engineer the simulator, eventually they will find the private key. So I don't know why they are so protective about these IPs. But this would need some support from the vendors, and there's no way to open source developers add support for this, unfortunately. But, well, so this is my talk, and thank you very much. Any questions?
Thank you, Augusto, for this very deep and complete overview of the landscape. Questions?
Thank you for the nice presentation. I have just a simple question. For the VHDL, how one can decide between GHDL and NVC, which simulator to use, for example?
Sorry?
For the VHDL simulation,
yes.
between GHDL and NVC, how one can decide which one is
better,
more suitable, or yeah?
I would say that both have a good support, mainly for VHDL 2008. We use both, but I have been recently using NVC more and more because, especially for VHDL 2019, that NVC has a much better support. And also because NVC has this mixed language simulation. In our lab, we try to standardize development using VHDL only, but there are some designs that have some Verilog modules inside, so NVC has been a useful tool to simulate these mixed designs. But GHDL has a mature support for VHDL, so, and if you have any problems, you can open an issue in Tristan, we'll solve it in a few days. So it's a good extended simulator.
Is there any difference for the simulation time?
Yes, there is. Well, depends on the design, but what I see is NVC is quicker. Yes, it's faster. You're welcome.
I was wondering, okay, first of all, thanks a lot for the presentation. That was a very nice overview. So you were talking about mixed language support with MVC. So I'm curious, what are the issues if they have a timeline to have a full Verilog, or I don't know if they also have some system Verilog implementation already?
Yeah, I think it has some system Verilog support. If you do a quick overview of the comments on NVC, I saw some simple system Verilog support that has been added recently. So I think if you have something that is easier to implement, so I have a design that uses system Verilog, and this construct is not supported yet, you open an issue. If it's not a too complicated construct, NVC, I think Tristan will, Nick will add support for this quickly. And I would say also it has some basic support for system Verilog classes, I think. But I didn't exercise too much because I'm not a Verilog developer. So I mostly used for designs that had some Verilog, synthesizable Verilog core. So of course, support for the synthesizable subset of Verilog is much more consolidated than more abstract Verilog.
Hi. So I was wondering if you know about any efforts for shared simulator and waveform integration, right? For example, if I open, let's say, Vivado, then I can, start the simulation, pause it, stop it.
Yeah.
And as far as I know, for the simulators, you have to write the whole waveform and you open it. Is there any support to improve this, or do you know of any?
That's a good question. Actually, there is some effort from the Surfer developers to integrate with NVC. I like to watch the comments and see the issues because these projects are evolving rapidly. And what I saw is that the Surfer developers are trying to use the VHPI API from NVC to integrate NVC with Surfer. And this would be very interesting because it will allow some kind of more complex debugging, and it would run just like a commercial simulator that open a window and do the simulation. So, but yes, for a long time with open source simulators, you have two completely separate steps, like doing the simulation, dumping the waveform, open with another program to see waveform, and the flow would be that. You could not call the simulation or do something interactively using the waveform viewer.
Thanks.
You're welcome.
Last question. If no, sorry.
It doesn't work.
Thank you for daring to compare different packages to each other in an open talk. And I also thank the organizers of this conference as to try to extend kind of the cooperation and the comparisons of all these open source frameworks. Are you aware of any other comparisons to see how these various frameworks or packages compare? And like in some cases you said like, this is written in C, so it's kind of old. I know GTK, GHDL is written in ADA, which is maybe also a bit a hurdle for contributing to it. So I think it would be really nice if there were more of this kind of comparison that you made. Are you aware if there is more of that?
Unfortunately, I'm not. It's something that I compiled over the years. I've used both the tools, but I never saw a website that did a good comparison, even though because NVC is very much recent compared to GHDL. So NVC started to become popular, I think, about 3 years ago. So it's a recent development, so there's not much comparison between these tools. Unfortunately, I saw some comparisons between Icarus and Verilator. And if you search on the web, you will find some overviews of both the tools, the limitations, and the advantages. But a complete overview of these different tools I never saw. So I thought it would be a good topic for the talk because it's something that is not easy to find on the web.
Thanks for the long answer. So maybe one point is then, if we are all here together, could we not try to get to that?
Yeah.
I'm not sure how to do it, but that was something that I wanted to point out. Thank you.
Yeah. It would be very interesting.
yeah, at least we can discuss that outside, and maybe we can encourage for the next sessions to invite some developers of those tools to come and present what are their plan, or yeah. So this is something we could try for next time. Let's thank Augusto again.